All right, here we go. Recording OCWG meeting number 15. And yeah, just the recap of what we've been talking about so far. Max has been working on getting the spec 0.2 merged into the main branch, which will basically be, at this point, I think spec 0.2 would be a spec that could be implemented. Like we should try to implement it at this point. Not that, I mean, Michael, you've done some implementation with the older spec, but as more of a
Yeah,
proof of concept, I think we're ready to actually give this thing a try. So,
yeah, for sure.
um, Michael left some comments on Max's PR, which we're going to go through real quick. So, go ahead, Max.
All right, excellent. So we have first, no, let's start with the second point, rotation. So the rotation center of a node should logically be the same as the point that is used for positioning, which in the spec we said is, I think, top left, because that's apparently the standard in this tool space. So if top left is the point you position, then probably that should also be the point you rotate around.
Rotation. Yeah.
And
Yeah.
I'll just change that in the spec. I took a note. Then about the
Mhm.
styling, I added some weird CSS and I'll just remove it. No problem. And then about the resources, last time we already had some discussion about things with an ID. So if we address stuff by ID, why don't we put it in a map? And this is
Yeah.
an aesthetic problem, not so much a technical one. So I found an argument why putting it in a list might be better. If we have two files and merge them, or we have one file that we manually mess up and accidentally introduce the same ID twice, and we parse that file, then the usual parsing technically will be a JSON parser, parsing it into RAM, and then some other code looking on the JSON and trying to create useful in-memory data structures and actually throw validation errors. Like here you have a node with the same ID twice, and that's not allowed, and here's how to fix it, blah, blah. But if we use a map, then the first JSON parser will say, this is illegal JSON. You have the same object key twice, end of story. And then there is no useful validation message because it's already technically structurally broken. And so due to the reality of how this parsing works, using arrays with an ID field will result in better validation error messages. It's not a strong argument, but it's one I found.
Yeah. Sounds
Yeah.
good.
And in the simplest case, you can just a very simple logic here when combining two files is just concatenate all the arrays. And
Yeah.
don't do validation, or like that you could make your
cross your fingers.
Yeah, exactly. It's probably going to be invalid and you want to run it through a validator, but you could at least, there's a simple algorithm for that will guaranteed no conflicts of just concatenate the arrays.
But the spec has covered your back because we say the IDs should be unique, and if they are not unique, we take the first one. And so we're not dying. At least we suggest that implementors should not die, DMs, but they should just render something weird and show an error message. So it's more hackable.
It feels like the HTML approach of like the way that browsers go to great lengths to render broken HTML. Even though we all know it shouldn't be formatted this way or that way or the other. But they're like, we'll make it work.
Yeah, for the notes we discussed earlier, some meetups ago, that the order of the list is also the order how it's rendered.
It's at least the fallback Z order.
Yeah, but although you also can use the Z index for that, I think.
Yeah, if it is defined.
Yep.
And it's also, and actually you can do the same with if it would have been a map. But
with just done the same with what? If it was a map?
The order.
You can also use that same order.
But
Mm.
this is even
That's
more
one.
tricky because it's now a JavaScript standard that maps have an order, but I think it's not a JSON standard that JSON maps have an order. So if a JSON map is by default an unordered bag, then the JSON parser might show it in any order. Like if you use, for example, a Java map, a hash map behind the scenes, then the order is actually not defined.
Yeah, I would not depend on ordering here. Like I didn't even know that the new JavaScript standard is that maps are ordered. That sounds fairly recent. But maybe I
There's
just
at
haven't been
least
paying attention. Yeah,
somewhere in the spec a way to retrieve the keys in the defined
just in order.
order.
Got it.
Maybe that's not even the standard, but it's possible now.
If I'm
Got it.
if I'm not mistaken, even in a standard JavaScript object, when you also that you can pass through to all the properties that are in the object in the order they are stored.
Yeah, I
If
think
I'm not
now it's,
mistaken.
I'm not sure if all iteration options have the standard order defined, but there is at least
Mhm.
one way to be ensured by the JavaScript ECMA standard that this is now in the correct order. Maybe
Mhm.
all of them, I just don't know. Anyway, in JSON, I think it's less defined, and so we should
Hmm.
certainly not depend on JSON key order.
Yeah.
Mhm.
And yeah, I would suggest to keep it being lists for pragmatic hackability reasons.
Yeah. Yeah, that
Seems reasonable to me.
sounds very good.
Right.
Okay,
We should probably document our reasoning there, because
yeah, this is
I'm sure that
a
Maybe need
great
some.
candidate for the design decisions document, isn't
Yeah.
it?
yep, it
Okay,
can be
then.
nice and short. Write an ADR for that. So,
So now, while I wrote down the spec, I stumbled upon some issues that we haven't thought through
all right.
so well. So maybe we can sort of together look at the spec and see what came out of it.
Mm-hmm.
I'm looking for the screen share option. I think I'm not
Oh, yep. Hold on.
allowed by default.
Yeah, I gotta enable it. Okay, you're good.
Oh, I have it. There's a great blue green share button. Just found it. So this is okay. Now I only have Zoom is weird. Why
Say that again.
why do I get this very, very small just because I'm screen sharing? I have multiple monitors. Okay, yeah. Um, so here you see the very nice CSS tag network.
Yeah.
So it could look nice. Ah, yeah. No, that's
Yeah. And in
too
my case,
large.
that orange bar was also in the front of the whole document, not
Yeah,
just
that's
how it's
certainly
how you.
not not the intention. Okay.
Yeah, I see
So
it. Yeah.
what do we have? This is all non-controversial. Yeah, these issues should nodes in JSON be an array or map. This is what we just decided. These should all be arrays, and we can also say why.
Yeah.
This is all non-controversial. This is fine, no issues. Okay, so we have nodes and they have these default properties. Then we have the first extension. So the ports,
Mm.
as an
I,
example, I turned into a node extension, which is, I think, what we discussed a while ago.
Mm-hmm.
So this is how that looks in JSON. So in the node, you have the data array. This is where we put
Mm-hmm.
all the extensions, formerly known as properties.
Mm-hmm.
Then we add the type. And this extension has a ports array as defined here in the ports extension. So every extension is described by a name, which is
Mm-hmm.
just a convention. I mean, every local the canvas could use its own name, but the URI is the mandatory name. And then it describes the properties it uses in its extension. And here we see an example of the extension being used. So this is simple and understandable. And every extension author should sort of produce this snippet to explain what's actually happening in the extension. And then as another example, I also wrote down the relative constraints extension. This is now just a suggestion from my side. We never discussed it so far. But as an example, you could say you have a port that's somehow placed relative a node placed relative to another node. So you say the source node to which I refer, and then I have a local position and rotation, but actually my numbers are added as a delta to the position of the other node. And that's it. So for position and rotation, I missed to describe how rotation works. Okay.
Yeah, I like this. Yeah.
That's
Can you give
another
me some
example.
examples of where you'd want to use relative constraints? And like, does that mean that you would not specify the position? Isn't position required at the top level already?
Yes, of course. But if your app understands this extension, it knows that this other node is always placed 0.5 next to the A node. So if the A node is going to be moved and the other app does understand it, it could like move the B node next to the A node because that's what the relative constraints extension wants to express.
That's interesting. I would have expected that to be expressed with like a set of a group, like a relation, a group relation.
Yeah, that would also be possible. And
multiple ways to express it, right? Like they don't all have to be the same. So
no, we should reconsider this, and maybe your idea is good, and we should actually change it. But let's leave it for a moment because relations, which we come to next, are slightly harder to understand. Okay.
All right.
So we have a relation, and relations are really simple because a relation has as basic properties only some kind of ID, just like nodes have. They have a type, which is actually a schema name or a schema URI. And we have the data array because a relation can have extensions on its own, like visual nodes can also have extensions. So if we have a set relation, we have a type. A set relation has a member, has the member property, which is of type ID array. So this is how you use a member relation, which is very nice and clean.
Yeah.
And then you can have an edge relation, which is from and to, and I also gave it a Boolean directed or not, and you can have a rel type. This is to model the RDF relation type. So it goes from this subject to this object, and that's the property of the triple. You can optionally put it right there in the edge if you need it. You can also write relation is worked at and just use a string. That depends on your app and use case. So this is still gentle.
Yeah.
Then you can have hyper edges, and there I went a little bit over the top and just modeled every possible hyper edge you can have because I know exactly what to put there. So the hyper edge also has a relation type, just like the normal edge, but it has more endpoints. The endpoints here actually are an array. You can have any number of endpoints in your hyper edge. Each endpoint is its own object, has its own target ID to which it links. Like an edge has a from and a to, but this hyper edge has many more endpoints, not just from and to, but maybe 17 endpoints or 3 endpoints, we don't know. Each endpoint has a direction. So an edge is a little bit like a blob between the nodes, and some nodes flow into the edge, some flow out of the edge, and some are undirected in relation to the edge. That allows you to model directed hyperedges, undirected hyperedges, and even all these mixed weird cases. Okay, you can also have that.
Okay.
Then you have weights. You can have a weight for the whole edge, which is quite common. You can have a weight for each endpoint, which is rarely useful, but I have some cases. If you do edge bundling and like your model flows and two flow together, and then the edge has a weight of 4, and then it splits into 4, and each of them has a weight of 1. Then if you render that aesthetically, it looks really good if you know exactly how much flow you have at which endpoint.
Mm.
So the weights could be helpful. This is like, we probably won't need more edge types given edge and hyperedge.
Mm-hmm.
So this is nice, and it's still almost compact.
Yeah.
So
Bad.
then we have the group relation, which we discussed. So a group is like a set and has members.
Mm-hmm.
It has a bit more semantics defined. For example, we explicitly say that groups can contain other groups. When a group is deleted, all members are deleted.
Mm-hmm.
When a group is ungrouped, the group is deleted, but the members remain. And I think this is a section of the spec that has to grow in length and precision for the other parts too, because this is really the meat. I
Mm-hmm.
mean, when should I use a group? In my app, I'm doing this and this and this. Is that a group by OCWG or not?
Mm-hmm.
And then you have to look up the semantics, and then you understand, yeah, that's exactly how it should behave in other apps that using a group.
Mm-hmm.
Then we have parent-child, which is, I think, what Jin insisted we need for inheritance. So we have a parent and a child link, and we can say inherit is true or false. Exact semantics of inheritance are defined by the application. This is a bit
Mm-hmm.
vague by the moment, but we can, yeah, tighten it if we learn more
Mm-hmm.
what to put there. Maybe,
Remind me what Jen's use case was for inheritance. He had a good example from a 3D
yeah,
modeling
like for transforms, you say you have some nodes, you group them, and then at the top you add some group node, and then you say you have a rotation, and then all the other nodes underneath should inherit that rotation angle, and you only define it once, and they all rotate, which is different. Each member rotates then, not the whole group as a whole. So it, right? Um,
Ah, I
or you
see.
define a background at the top, and all the members should get that background in its content. So it's
Interesting.
property inheritance, a bit like in CSS or
Yep. You're defining
template
kind of a
based.
rule that you can then inherit around the different places.
Yeah, yeah,
Interesting, because those are typically what we would think of as node properties, data on the node. And we're using a relation to express that
yeah,
inheritance, an inheritance of node properties. I don't know. That feels
yeah.
weird.
Yeah, yeah. So you have a template node, and the other ones apply the template. So I think that's a good candidate for a relation, actually.
Mm-hmm.
Um, then we have, actually, I'm not even sure that this is the most recent version, because yeah, yeah, I remember. So then we have assets. These are, I think, less problematic. We know we have resource and schemas, and they're similar yet different. For assets, for resources, we can put them inline, external, and remote. We define location, MIME type, content. This was all easy. A bit tricky are the data URIs, because if you have a data URI, they implicitly
Mm-hmm.
already define the MIME type and the content. So, but yeah, so if the user also stated MIME type, that should be ignored because it's already defined in the URI, and
Mm-hmm.
to actually define it and override here, it doesn't make much sense. Then we have the fallbacks defined.
Wait, can you go
Of
back to that example real quick? Do remote,
The
in order for a remote data URI to be valid, does it have to have a MIME type?
data URIs always have a MIME type, yeah. Otherwise, they
Okay.
are not data URIs.
Okay. Gotcha.
Yeah.
Cool. So in that case, if you were to specify the MIME type, oh, I see. You're saying in this case it's binary and inline content is set as the remote data. Okay, I got it. I understand now. Okay,
Okay.
cool.
Yeah. Then schema. Yeah, we probably need some kind of tooling for validation, but this is not really
Mhm.
an issue in the scheme in the spec per se, but rather, yeah.
I mean, that's reasonable. Like you're saying, okay, so a schema is defined as that table right underneath that each entry is an object with the following properties, a URI, a schema object, a JSON schema inline as a JSON object. Got it. And then the location and the name.
Yeah, and then it depends a bit what you define, what's required. So you can have an inline schema, then you always need a URI, and if you have an inline schema, you need to actually state the schema, otherwise we don't know what the schema is.
Mm-hmm.
Um, if you have an external schema,
Mm-hmm.
which is a relatively local file, then you need to give that path so that we can find it.
Mm-hmm.
And if you use a remote schema, and the URI actually does resolve to the schema, then we can find it there. That's cool. And in any case, you can give the schema a name if you want. And if you
Mm-hmm.
gave it a name, then in the other parts, you can refer by name and don't have to state the URI.
Mm-hmm.
So this is just nicer and shorter than the long form.
Got it. Got it. And the name, so
But
the name is the key to the map right here in your example.
yeah, exactly. Yeah. Which actually makes it quite funny because how can a name be optional if not there? So that doesn't
That's
work at
what I was
all.
just gonna say. Like, wait, then how do you specify it?
Yeah, okay. So now we have
So
two
the name is
options,
required then,
or we turn it into an array. Um,
which we're using elsewhere. We would end up with the concatenation problem again here, right?
well, the
The
schema array is super short and yeah,
But
I
I mean,
mean
it's the same problem you mentioned. I mean, it's
it has
less likely to happen.
it's a kind of consistency to use just arrays everywhere.
Yeah.
Yeah,
So
I,
that's
I kind of feel like consistency wins out here a little bit over the readability.
Yeah.
all right. So I took a note to change it to arrays.
And that also makes
Um,
the name truly optional. Like you
yeah.
can, if you want to, you can leave the names out. You can spell out the full URIs of each one of the.
Actually, you don't even need that entry if you just use the URIs throughout your document.
If you use the URIs to what?
If you use URIs to reference an extension
Uh-huh.
and not the name, then why do you need an entry here? If you have a resolvable URI,
Yeah,
then you don't
that's a
need an
nice
entry in the
shorthand.
schema. You can define it here, but you don't have to. You can just leave it out and
Right.
use the URI.
Did you mention that up above? That's like a shorthand. You don't need a schema entry if you would like to use a fully qualified URI for a non-inline, for an
I think that's
external
not
or remote schema.
not clear enough yet.
Seems like a reasonable thing.
Yeah, so it's
I
purely
think I think
optional.
our preference though is that these schemas would be self-contained, right? That's kind of one of the sort of local first values, or at least my preference would be that you would actually include the schema uh, in the file itself. Um,
It has pro and cons. So that would say that every exported OK files everywhere contains all schemas, which is
just the
not adding
schemas
so
it
much
needs. I
value.
mean,
Just the schema, what?
just the schemas it needs for that file, just the
Yeah,
schemas for the
okay.
nodes and relations that are defined in it.
Yeah, but what's the value? I mean,
The value is you can open it while offline.
You don't need a schema to open a file.
True.
The schema
Is
is
that
more
true?
for, yeah,
No,
it's just adding extra validation. Actually, the URI is the key, and you either understand the URI and know how to handle it, or you don't.
but I'm imagining myself as a um, infinite canvas tools author, and my thinking is that I would load the schemas and load the JSON schemas in order to dynamically build objects that I could then load so that I would want to do that validation myself as I'm loading in the OCWG file, or the OCIF file.
But for reading JSON, you wouldn't need the schemas.
No, I understand.
The schemas are just constraining
Unless
the
it's
space of,
malformed. Yeah.
yeah, they just constrain the space of legal JSON
Right.
structures.
Yeah, and that's what I was saying. As an author, I would want to do. Ideally, I would say, give me the JSON schema so that I can put these objects together, and then as I'm loading the file, I can catch any validation errors as I'm loading it.
But if you don't understand that part of the JSON tree, let's say that's the ports extension, and you don't know what the ports extension is, you don't gain anything by saying some of the ports arrays are valid, some are not, but I don't know what ports arrays do at all. So
True.
what do you
That brings up a really important
gain?
point. Um, I think there should be a description field for extensions. So bear with me
Yeah,
here.
right. Yeah,
Yeah.
something like that.
Like free text where you can say what the extension does for a couple of reasons. One, for human authors, of like, how does this extension relate to, the canvas at all? And that could be, so, you could describe how you expect this extension to be used. But the other reason I'm thinking is for like LLMs that would consume this um, file format. They could actually learn about each one of the extensions by reading the description. Um,
Yeah, maybe. So let's park that one too. We are almost done, and then we need to talk more about extensions.
Great.
So we have we could add some built-in schema mappings
Mm-hmm.
to say these are always just built in.
Mm-hmm.
And yeah, here we come to one interesting point. So we have node extensions, nice. We have relation types, nice. They have schemas. And then we have, of course, relation type extensions. So these are, let's say we had the set, and now I have an extension to the set relation type. Then we have the set. Of course, it has a version. All our schemas have a version. So we have a set version 2 with an extension version 5, maybe. And version 5 of that extension applies, of course, only to the set extension in version 2. And then if a set extension version 3 appears, then the extension authors to this set relation types need to reconsider whether their extensions
Mm.
still apply and port them and so on. And this
What
is
if we what if we flattened it here and said that extensions don't apply to relation types? They apply to, like, every relation type is an extension of the base relation, just like every node extension is an extension of the base node type. And that way,
then
all of the ones you defined aren't relation types, they're just extensions.
then a relation type can at the same time be a set, an edge, a hyperedge, a parent-child relation. And that is really tough to interpret.
This is true. But I mean, I could make the same argument for a node could at the same time be a rectangle, an arrow, a circle, like, you could just stack extensions on top of a node and make just as much gobbledygook of your file as you could with a relation.
Yeah, that's true. And flattening it and turning every relation into an extension of the base relation just simplifies the space here. I like that.
Cool. Yeah, and it makes it nice and parallel. It makes relations even more parallel with nodes.
Exactly. And this is one thing that really I didn't like about how it turned out.
Well, I'm glad. I mean, I think you put your finger on the problem. Now, this is just a possible solution. You're right. It is awkward. Um, that possible solution, I'm trying to think of if it boxes us out of anything in particular. Um, I don't think so, but I think what you were trying to capture was also valuable, which was there are these relation types that are kind of default or included, or it's like the default set of extensions. Um, and these are the ones that are defined in the spec. And so they don't feel like extensions. They feel like first class extensions or first party extensions. You know what I mean? And I feel like we have the same thing that we haven't really done yet with the nodes, where we're like, these are going to be the ones that OCWG is going to kind of ship with, but we're still treating them as extensions no differently than the rest of them.
Yeah. If
So I think
we
I appreciate what you've done of going further to spelling all of them out, because we need to do that on the node side and haven't yet.
So if we say we have a set extension and that's it, then it's not possible to attach custom data to sets.
We say we have
in order to do that, you need to define your own set, and there's no hint that your set has anything to do with my set. Ah, no, it's still in the same relation. It has just two extensions, the set extension and the other one. That's actually fine. That works. That's like multiple inheritance.
Yeah, it's like we talked
Works.
about with arrows. We talked about this with arrows too. There's going to be an
this
OCWG
works.
arrow and a TL draw arrow.
I like that. So technically, one other thing was slightly interesting. If we have a relation, let's go back to an example where we use an extension. Yeah, for example, here. Here we have a normal JSON object. It has a type key, a value for that key. It has a type, an endpoint key, and a value for that key. And you can put any keys you like, except the type key. That belongs to us. That's the magic key. And for a magic key, it has a surprisingly common name. So if you want to call anything a type, don't call it underscore type or call it, I don't know, find another word. Type belongs to us.
It's a reserved word.
Subtype.
Yeah.
But is it still a reserved word now? Like, I thought we were.
Yeah, of course. All our extensions are of this shape. They have a type and then they have other properties. That's how we put them.
Yeah.
So.
Can you show me a node extension as well, just to jog my memory?
Yeah.
I guess I could look on the file on my side too, actually.
So here we have a node with an extension. It has the ports extension active on it. And of course, it has a data array. And in the array, you have the extension objects, and each of them has magic type.
Yep.
And that's just a reserved keyword. And
yeah,
I don't know.
So you're saying that type might be too simple of a name for such a magic word?
Maybe. We could also call it OCWG, OCIF or OCIF type or
EXT
type or like, EXT type. Yeah.
Because that's what it is. It's the type of the extension. So it could be like this.
I think it's already a nice improvement, EXT type. Michael, do you have an opinion on this aesthetic idea?
I like type the most, actually.
Yeah?
Yeah. Because because it is nice and simple. One word.
I'm ambivalent either way. EXT type or type both feel good to me. EXT only adds 3 characters, so
but we can stick with type for the for the point being and see what others say. We're just three now, so I just want to
Yep.
bring up that this is the only magic key in that set. And it's the only kind of conflict where we do have that.
Mm-hmm.
And don't nodes themselves need a type?
No. We just
Yeah.
discussed
Yeah,
how we unify actually nodes and relations. So nodes have no type, but they have extensions with a type.
Oh, yeah,
And
yeah.
relations will also lose their type and just have extensions with a type. And that way,
Oh, yeah. That
relations
makes
have
sense.
multiple types if they need to.
right. And
So type
it's
is not wrong.
implied that something is a node because it is in the node array. It's
Yeah,
implied
Yeah.
that something is a relation because it is in the relation array. Therefore, we don't need to add a type field to it,
Yeah.
yeah.
which is nice. That's good. I like it.
We have not defined what a relation without a type actually is,
I was going to
but
bring that up. Yeah.
it's just there and empty, like a, I don't know, why not? You can have it. It's like a reserved ID.
Yeah. Yep. We have the base node type, which does have stuff on it. I mean, it's going to have an ID and it's going to have a data, and that's it, right?
Yeah, data is optional already. So,
Right. Data is
and
optional, but it
this
will have an
uh,
ID.
type will be removed and delegated into data, and then it's just an ID. It's fine.
I
So
think
be
so.
it.
Yeah.
Then, yeah, we simplified. I like that.
Yay.
Um, yeah, then we just have like a concluding list of the sort of types we use internally, which are more precise than the JSON types. So we have angles for rotation. What do we mean by an angle? Are they in radians or in degrees? So that's
Hmm.
defined. What's an ID in our spec? To what other IDs does it need to be unique? What is a MIME type? And I looked it up. Actually, it has to be called MIME type, not content type. Content type is just an HTTP, but MIME type is the generic
Hmm.
term. Um, yeah, then maybe do an IANA registration one day. Okay. Um, yeah, so the list of open issues is really quite short. So this is how this schema built-in stuff would look like right now.
Hmm.
And this will be reformatted to an array. And as an example, we have the extension. Yeah, now it's, I think, a good time to talk more about extensions. So right now, we only talk about the schema of an extension. And here in the spec, I already say a good extension is described by its URI, by a short name, by
Hmm.
a table describing the properties, by explaining the semantics of the properties, by maybe giving examples. And none of this can be found in the schema. So we have no agreed upon way how schemas are published, documented, how extensions are documented. So we could have like a convention. You should have a document that has this structure, these points. It should be named this way. It should be put there in your GitHub repo. And that's the usual way to find the documentation for the extension. That would be nice. And then we should follow that guide ourselves and maybe remove our relation types from this spec and put them in the extension folders.
Makes
Yeah.
sense.
Yeah, I'm happy to help. I'm happy to help write node extensions as well. This is something I thought a fair amount about um, when Orion and I started working on the spec, is like, what are the base nodes that are being used across canvases? So yeah, once we have a format, I can knock out a few of those.
Yeah, this
Um,
is sort of the first proposal for
Right.
most.
So I think what we're saying is
Yeah.
that there's like a GitHub repo or a file, a folder. Yeah,
You probably need, yeah, if we map this to HTTP, you probably need a folder and two
folder.
files, the JSON schema and the documentation file.
Yep, exactly. I was going to say the same. Probably a readme.md file is our recommendation, but could be something else if you want. The nice thing about readme.md is that it reads well in GitHub if you're browsing.
Yeah,
Like,
So we should use it to our advantage.
Yep. So I think it's a readme.md. It looks like it has what you've got right here of an H1, of the name of the extension, some common name of the extension. And then, yeah, schema, the name, the property, the schema links to the schema file itself, which is a JSON schema, valid JSON schema file. Then a table that shows the properties. This goes back to my thing about a description field.
Yeah, so this would be much more powerful than a mere description field in the file. So
I agree it's more powerful. It's not as easily queryable. Whereas if it's a description key, when you pull down the JSON schema, you get that description field along with it. I'm not saying that that's better. I'm just saying that it comes along with the schema itself. I do think it's better for machines like LLMs, of like you can hand them the schema, and you don't have to hand them a separate readme.md.
yeah, but honestly, for LLMs, breaking up the spec into multiple files would be a bad idea. For a machine, having it all in one document would be much easier to handle.
I think we should probably have like some tooling that does that, basically, that like this is why I was saying I want those inline schemas personally. I think it makes I want a tool that flattens it all into an inline schema so that I have it all in one place in a single file. There's TL Draw has like an example of this, I believe, where they have a JSON version, .json version that just has the data structure, and then they have a .tl draw file. I'm gonna go check my execs here, but they have two different files. One of them just has the data, and one of them has the data plus the schemas.
Yeah, that
fully fleshed out. And then the advantage of the data plus the schemas is you can have the exact version of the schemas in that file that were used at that time, or used to create that data, and you can kind of package it all up as a single file that can be opened offline by the TLDraw JavaScript viewer without having to connect to any schema servers or anything. If those schema servers aren't available, those schema versions aren't available, it's doesn't matter. It's all in that one self-contained file. And I've made the mistake before of getting the JSON file of a TLDraw and not having the .tlddraw file, so I didn't have the schemas. And I wasn't able to do a few things that I needed to do, and it was actually around validation. I had a weird validation problem with my JSON file, but I didn't have the schemas available in order to do the validation. So I had to go back through their repo and manually pull them down. It was kind of a anyway, that long story, but this is why I think having schemas hydrated in a file can be really useful.
So would we then have two flavors of OCIF? The OCIF pure and the OCIF hacker version of a file?
What's the difference between the two?
Pure is just the data, and the schemas are just linked.
Well,
and hacker is the hacker-friendly version where the schemas are all inlined.
I think both of them are valid OCIF files the way you've defined it, right? One of them has external URIs for the schemas. I just think we should have a tool.
But should we? I mean, if we write a spec, we should tell dear application author, what should you put in? Is it common practice to always put everything in, or should you offer two export options, or what?
Yeah,
what should be done? I mean, it's on to us to decide.
Right. So the way, if I were writing that section, and this is just me, and I mentioned this already, the way that I would write that section is I would say our recommendation is that you bundle the schemas with the file for the sake of having a complete file that can be opened offline, that can allow maximum flexibility for infinite canvas authors to be able to do that full validation without having to hit a remote URI. all that. That's the recommendation. But if you want to save space, like if you want a smaller file format, you can omit the schemas and pull them down from an external URI, or package them up as an inline or a file alongside that they can, like a local URI, if you wish. And that could be that maybe that's the OCIF bundle that I was just referring to, like the TL draw bundle that has, because you could actually have the data and the schemas separately, and resources. There could be some kind of OCIF bundle. But yeah, that's the way I would write that section. Is recommendation is
To put it
embedded
all in.
all in one place. Yeah.
Yeah, okay. That's fine.
And I think we can offer like a command line utility that takes an OCIF file in any format and then hydrates
Yeah.
it.
Yeah,
And it could
that's
do the
always
same thing with external resources as well, by the way, which would be pretty
yeah.
cool. Like
Yeah.
turn them all into local data URLs, and so you end up with this like 5 or 10 megabyte OCIF file because it's got all the local resources in it. But hey, it's got all of them, right? Like that's
Yeah.
so.
For the spec, if we put the description of the extensions in separate files, then the spec itself would be harder to read and less great for LLMs, because managing multiple files is not so nice for LLMs. So
Yeah.
there we would also need some kind of bundler to create like the long version.
We could do the silly, like a very simple version of that, which is basically just concatenating markdown files. So we could specify our bundler could basically be, here's the full spec in the nodes section, an array of OCWG nodes types that we say are kind of the default. And we just literally iterate over those, grabbing those readme.mds. And then, so I think I could write that bundler for us
All
if
right.
we follow this readme.md format, right? Where the readme can be just literally embedded, like concatenated inside the file.
But this is how the README MD should be formatted, so that this concatenation actually does work. I mean, that would be. But okay, you also need some heading indent adjustment, and headline 1 becomes headline 2, something like that.
Yep, that is true.
It's
I was thinking the same thing.
It does work in ASCII, dog.
I think you're gonna have a hard time selling that one, Max. I know you like ASCII doc, but
I think for
Okay.
pragmatic reasons, it would make sense to leave the bundle default extensions just in the main spec, and maybe as an example, say how that would look like in a README MD.
Yeah, I think that's pragmatically, I think that's entirely reasonable to make it one easy readable doc. We can even link to we can have a link inside from the main spec to each child, node extension to each node extension and relation extension that links to that folder where the README is and that kind of thing.
But it's super cumbersome to maintain. So for the built-in things, we would in the README say, actually, this particular built-in extension isn't documented here like it should. See the main spec. That would be very, very pragmatic. And then we have one example extension where we say, here you actually see as a template how that should look like.
Okay.
And
All right.
that's it. That minimizes maintenance burden.
I like it. Sounds good. So then as we iterate on the versions of not the high level version of the OCWG spec, but as we iterate on the versions of the extensions, we will have to make sure to update the main spec.
Yeah.
But we're gonna have to update either way. So
we need to decide hard which are really built-in types, built-in extensions, and which are not.
Yeah. I think that's a great topic for next meeting of like, let's go through our list of, I think you've already done it basically for relations. Now we need to do it for nodes.
Yeah. And maybe a last thing is, What do you think now about the relative constraints? I mean, obviously
Yeah,
it
this
could
does
be
pop all the way back up.
it could be a relation. It could also be a node extension. And it's very, I don't know, it's not very structural or semantic. It's addressing the visual properties like position and rotation of one node, relating these visual properties to the other node. So I don't know, it felt closer to the visual domain. So it's a visual node extension. But we
I think
could
it's fine
also,
as visual node extension. I'm not, yeah, I think it could be implemented either way. You could implement
certainly,
it
yeah.
as a group extension with where the group or set with either one, a group or set has like a relative property on it. So you could call it a relative set or something along those lines. Now
That would
yeah,
make it more powerful, maybe.
that feels so the difference, I guess, is that yeah, that would make it more powerful because then you could have wait, because this extension it doesn't have an array of
No, it's you put it on one node and say this node is actually positioned relative to another known node. And my relative delta is the
yeah.
position of that node plus this and the rotation plus that.
Okay, so I would define I think it's better as a relative set because in the relative set you can basically specify an array of all of the nodes that are relative to the source node.
But you
Um,
need not only to state the IDs of the relative nodes, you also need to say what's the offset. So you
right.
need an array of the same length for all the offsets.
Oh, yeah, you're right. Okay, I
And
see.
then you make sure
Yeah.
that the arrays have the same length. And
Yeah, that is kind of dirty. Yeah, no, I think you're right. So it is a node extension. Uh, yeah.
at least for now.
Yep, for now. No, I think you're right. And what made you, or are you proposing it as a like built-in or a default one, whatever we're going to call these Christian ones?
Yeah, but this was just to, I don't know, we had some notes on that topic, so I wanted to put it somewhere. And
Great. Yeah. No, this will be a great start. And yeah, I like it. Michael, what do you think?
Well, these relative constraints extension, I can see that it can be really helpful for something like Spring, like some kind of Spring behavior that you want to build in or define, but that those nodes are not in a group, but there is a constraint between them and how you
Hmm.
move together. So I like this relative constraints extension that we have this in the spec
Very cool.
besides the normal relations.
Hmm.
yeah, you can now take a hard look at what we had defined and think what's missing to define your tool in it.
That's exactly what I'm planning to do. I'm planning on looking at TL draw and Excala draw like we've talked about and going through. And the other one that's very simple because it's just such a simple spec is the Obsidian Canvas spec.
Yeah,
Very,
if
very
we
simple.
cannot express that one, we did something wrong.
Exactly. I think we can capture that one pretty quick. So
Yeah.
I'm curious to write an actual OCIF file that captures everything from Obsidian Canvas, like an example. So that'll be fun.
I will convert change my implementation for my exporter.
You'll have the
So
first tool that implements OCIF 2.0.
I hope so. If I can find the time.
Sorry, 0.2, not 2.0, 0.2.
All
Great
right.
work, Max. This is really good. Yeah. One
All right.
logistic question before we jump off the call, and I'll go ahead and hit stop recording for now.